we're going to try this word problem, and we're going to try solving it by completing the square. So Bob wants to cut a wire that is 60 centimeters long into 2 pieces. Then he wants to make each piece into a square, and you want to determine how the wire should be cut so the total area of the 2 squares is as small as possible. So let's just draw out our wire first. We're going to start off with a sketch. Let's get that going here. So I'll start off with a sketch over here. This is our wire, and we're going to cut it. We don't know how it's going to cut. The only thing we know is that the total length is 60. So if we cut it and one length is x, the other length must be 60 minus x. And then we're going to take these 2 pieces and make a square with them. So with this one here, I can make a square. The whole perimeter of the square must be 60 minus x. Now since it's a square, what that means is that each side would be 60 minus x over 4. Right, because if this was 8, then each side would be 2. And then with this one, we'll also make a square. All the sides are the same here. The entire perimeter must be x, because that's the length of the string. So since there's 4 sides, the length of a side is going to be 4, x over 4, right? Because we're dividing by 4 sides. So we can write a few expressions down already. We know that the area, let's call this square 1, the area of square 1 is 60 minus x over 4 squared, because you do length times width, and the same length and width. And we know that area of square 2 is x over 4 squared. And we also know that the total area of both of these together would be total area, so A total. The 2 areas added together, A1 plus A2, so 60 minus x over 4 squared plus x over 4 squared. And so what we're going to do is we're going to expand this. I'm just going to call my area total y now. I'm going to call it area total y. So just so you don't get confused, I'll write that down. Area total, we'll call it y. So y will be equal to 15, that's just 60 divided by 4, minus x over 4 squared plus x squared over 16, because that's x squared here, and then that's 4 squared, which is 16. And I'm going to continue expanding, so y is equal to, so just expand this by basically writing out your 2 brackets like this, and do your FOIL. So we get x squared over 16, because it's minus x over 4 times minus x over 4. And then we have, so minus 15x over 4, minus 15x over 4, so minus 30x over 4, and then plus 225, and then plus x squared over 16. And we can group like terms and simplify, so we get x squared plus x squared, so 2x squared over 16 minus 30x over 4 plus 225. And we can simplify a bit more. We get y is equal to x squared over 8, because that cancels out, that becomes 8, minus, can we get 15 over 2? Yes, we can do that. Minus 15x over 2 plus 225. So far, we have this expression written out for the total area of the two squares added together. And so what we need to do is figure out, well, what is our length of x going to be to get us a minimum area? This here, you'll notice, has a positive a. So that means that a parabola opens from the top and our vertex will be a minimum. So if we can find the vertex, then we've found the minimum. So let's continue to find the vertex. We can do that by completing the square. So we can have y is equal to x squared over 8 minus 15x over 2 plus 2, 5. We can then factor out a common constant. So we could take out the 1 over 8. Let's just scroll that down a bit. We can take out the 1 over 8. So y is equal to 1 over 8. It will give us x squared. If you do half that by 1 over 8, that's going to be 4. So minus 60x plus 225. I just did basically 15 divided by 2 divided by 1 over 8 to get that 60x there. I'm going to find the value required to make this a perfect square. So I just do minus 60 over 2 squared, which is minus 30 squared, which is 900. So I'm going to get y is equal to 1 over 8 x minus 60x, x squared minus 60x, plus 900 minus 900, plus 225. And so now I have to send this out and multiply it by a. So I get y is equal to 1 over 8 x squared minus 60x plus 900. And then our minus 900 times 1 over 8. I'm just going to write it out this way as minus 900 over 8 plus 225. And then I'm going to go and factor by completing the square here using our perfect square method. So x squared minus in there, so 30. And then you can figure what this is by putting them on a common denominator. So minus 900. I'm just doing the work over here. It's a bit sloppy. You would have a nice, neater, neater work area. Plus, so 8 times 225 is 1800 over 8. And so that would give us 900 over 8. So what we found is that if our x value is 30, then we get a minimum area of 900 over 8 units squared. If you were to write this as decimals, which you shouldn't, well, you could in this case because it's a terminating decimal, you would get 112.5 units squared as your minimum area. And again, it's minimum because our a value is positive. And so it opens from the top and the vertex is going to be minimum here. So if our x is 30, so x is 30. Remember our string was 60. And we had cut it into 60 minus x and x. Well, now we know the value of x here is 30. So the value of this string here must be 60 minus x minus 30, which is 30. Therefore, 2 segments of 30 would result in the smallest surface area. So that was a question that involved a little bit of thinking. You had to sketch it out, draw your squares, and come up with equations that you could put together. And so I did that. I found the area of the large square, the small square, but again, they're the same length, so it doesn't really matter. They're not the large square and the small square. They're actually equal size, as we know now. But basically, I found the area of one square and the second square, and then I added them both together. I came up with an equation, and I found my my minimum value using my vertex method by completing the square. So I had to cut the pieces of string into 30 and 30. If I went one step further and said, well, what's the length of the sides of the square? Well, if it's 30 and 30, so if I use one string that's 30 centimeters, we know it's 30 divided by 4. So each side would be 30 divided by 4 would be about 7.5 centimeters in length. So we know that this now is 7.5 centimeters. And we know that this now is also 7.5 centimeters to make the square all the way around. So 7.5, 7.5, 7.5, 7.5. You add them together and that's 30. So it was a bit more of a challenging question, but notice that we still use our skill, and it's always about making those equations, those quadratic equations that you can solve or find the vertex in some way, shape, or form, and then you're usually on the right path. Sometimes, even if you don't know what you're really doing at the beginning, if you start by making equations, you might see something you can do. Basically, if you get to this step here, you can say, well, I need to find a maximum, so that's a vertex. And that's pretty straightforward. So you want to get to this point, and then you can find the vertex in the different ways we learned. In this case, we did complete in the square.